We are starting from group 1, elements known as alkali metals. Here we'll talk about their properties and production. Alkali metals are located in the leftmost position of the periodic table, starting with lithium, sodium, potassium, rubidium, and cesium. You'll never see francium, which is a highly radioactive element. All these elements are metals. Their metallic radius, so radius of atom in a metal, increases with the period of periodic table. So smallest is lithium, sodium, potassium, and cesium is the largest. Ionic radius also increases from lithium to cesium. Coordination number for lithium is usually 4, sometimes 5. For sodium, most common are 6. Same for potassium, rubidium, and cesium, the largest, often has 8. Ionization energy drops from lithium to cesium. Standard potentials, so the measure how strong reducing agent can be, drops from lithium to sodium and then slightly increases back to cesium. What's interesting is very low density of these metals. Density of lithium is twice smaller than density of water and smaller than density of most of hydrocarbons. Density of sodium is also lower than water. Same with potassium. The reason is very large size of all these atoms. Melting point of lithium is relatively high. All others melt below boiling point of water. Cesium is melting practically at room temperature. You can look at very nice video dedicated to mechanical properties of these metals. I'll just mention one particular property. They are very soft. They can be easily cut by knife. Preparation of these metals are done mostly by electrolysis. The most common, one of the most common electrolysis process in industry is making metal sodium and chlorine gas out of sodium chloride. Same process can be used for lithium. It is commercially inconvenient to run this electrolysis for potassium, rubidium, cesium. However, it's possible. So they use different reaction. For potassium, they employ the fact that boiling point of sodium is much higher than boiling point of potassium. So when there is equilibrium between sodium metal and potassium chloride and sodium chloride and potassium metal, when you run this process at temperature around 800-850 degrees Celsius, potassium will evaporate and equilibrium will shift to the right. Similar approach is used for making rubidium and cesium by using calcium metal and making calcium chloride, which has high lattice energy because of 2+ ion. Process of making metal sodium is so important that it has even its own name, so-called downcell. It contains cathode made of steel and graphite anode on which chlorine gas is formed. So chlorine gas is bubbling out of molten sodium chloride. In industry, they add some calcium chloride to this mixture, so the temperature of the melt will go down, because keeping the temperature at melting point of sodium chloride is very expensive.